Hey, there's a 50% chance that this coin will come up heads when I flip it. It's tails. So was I wrong in my forecast? Let's try another one. There is a 90% chance that when I roll this 20-sided die, I'll get above a 2. I got a 1. So aside from not making my saving throw for the lightning bolt the evil wizard just cast at me, was I wrong this time? Now hopefully you said no to both of these. See, my forecasts were probabilities, and they were correct when I made them. Now if I were watching this video, I'd be thinking, there's no way he got both those things wrong in the first take. Except that statement, I'd actually be wrong. Oh, it totally took me multiple takes to get the coin and die results. But let's rewind and review what I said. There's no way he got both those things wrong in the first take. I said there's no way. I made a statement of probability, but there was actually a 5% chance, right? The 50% times 10%, that I would get the alternate results for both the forecasts in succession. Now, at some point, when probabilistic forecast gets too large or too small, there's this cognitive bias called neglect of probability that kicks in. We just start to forget about the probability and sort of take things as certain or completely, not gonna happen. Now, this is situational. Like, it's gotta be tough being a weather forecaster. When we think about their forecasts, the neglect of probability bias really seems to just be always on. But here's the deal. Weather forecasters don't tell you if it's going to rain or not. They tell you the probability of rain, right? If they say there's a 90% chance of rain and then it's sunny, we can't tell if they are right or wrong on that individual day. We can only tell if we take a bunch of days that they said 90% chance of rain and then see what the actual percentage was. Now, it's not really a thing about being right or wrong, it's how accurate the percentage is. And oh, by the way, if it rained on 100% of them, they'd be just as inaccurate as if it only rained on 80% of them.
Hey Alex, that all sounds wonderful, but what does it have to do with product development?
I'm glad you asked. There are two connections to product development that I'll point out. First, there is variation all over the place in product development. Products don't perform exactly the same way every time, and the factors that influence how the products perform aren't the same every time. Actually, that's usually where the variation in product performance comes from, is the variation in the factors that impact the variation in performance. Anyway, to do product development right, you need to do probabilistic forecasting. So that's the first thing. Second, when you see a 20% chance of rain, that means that 20% of the forecasting models show rain. It uses a thing called Monte Carlo simulation. It's a powerful tool used in product development to do similar things, really. It takes all the variation from those factors impacting the response. By response, I mean the weather, the product performance, whatever the thing you need to be doing is. And it runs the simulation a bunch of times, like 10,000 times, 100,000 times, to create a probabilistic forecast. So whatever project you're on, try to just get rid of the neglect of probability bias and use Monte Carlo simulation if at all possible.